Hey guys, here's a homework problem here's a practice problem very similar to homework problem 7. And so it is asking us, what is the probability that an international flight leaving the United States is delayed in departing? And then you see this word given, and I'm going to color code the second part in a different color, that the flight is a trans-Pacific flight. So this term given is a clue that we're going to use something called conditional probability. So in this case, we have two events. We have event A, and I'm going to color code event A in the same color as the green because A represents the international flight leaving the United States delayed in departing, and B, event B, is the flight is a trans-Pacific flight. So what I've already got color-coded in yellow. So conditional probability is represented with this little symbol right here. And if you put it into words, it just means the probability that A happens given that we know that B has happened. So we know for sure B happened, okay? B is definitely a trans-Pacific flight. So given that information, what is the probability that that trans-Pacific flight is also going to be a United States flight that is delayed? And we use the formula that I have right down here in order to be able to calculate that. So P and A, okay, is the first part because that's what this means is P and A, okay, is actually given to us in the problem, okay? This is the probability that an international flight leaving the United States is a trans-Pacific flight and is delayed. So basically, all the conditions tied up into one little package. That is what this little symbol here in the middle, it basically means and. Okay, so the probability of both of those things happening is 0.13. Okay, it's given to us in the problem. And then the rest of the formula, we divide it by the probability of option B happening and the probability of event B happening. Okay, that is, event B, my bad, should be yellow. So the probability that the flight is a trans-Pacific flight is right here. The probability that's a trans-Pacific flight is 0.55. So we are going to take 0.13 and we are going to divide it by 0.55. If I do that, I get a decimal that kind of carries a little bit. It's like 0.23636, and it goes on and on and on. I believe your textbook asked you to round to 4 decimal places, so that means that this, in this case, would round to 0.2364. So the conditional probability is 0.2364. The next part of the question is asking you, are these events independent from each other? So here's the deal with things being independent from each other. If they were independent, then we should be able to use just a plain old compound probability formula to get the probability of both of those things happening. So what I mean by that is the probability of event of the departure issue is 0.28, and the probability of it being a trans-Pacific flight is 0.55. So the probability of both of those things happening under normal circumstances would be just multiplying those two numbers together. I would just do 0.28. That would just be plain old what's called compound probability. I would just do 0.28 times 55. I would just multiply those two probabilities together, and that would give me the probability of both of those events occurring. So 0.28 times 0.55 is 0.154. Now, that would be, if they were independent of each other, the probability of both of those things happening, we would just multiply them together. But we know from the problem above that that's not the probability of both of those things happening. The probability of both of them happening is 0.13. So there must be something going on about the fact that it is a trans-Pacific flight and that Trans-Pacific flight is leaving from the United States and is an international flight. So there must be something about that combination of factors working together that changes the probability. So because that 0.13 is not the same, okay, so because that 0.13, so the probability that we found in the first step of both of those events happening, what was given to us in the problem, is not equal to just multiplying the probabilities together. They must not be independent. There must be something about those probabilities that make them dependent. So we would say no, they are not independent events. I hope that this helps. If you have any other questions, by all means, please feel free to ask. I'll be standing by.